All right, so our last week of material that we're going to be tested on is on polar coordinates and complex numbers. 3 sections, 5.1, A4, and 5.3. So we'll spend a couple days on 5.1, and then, as I said, the appendix 4, that's review stuff, and then we're going to come back to chapter 5, but we skip 5.2. We don't do 5.2. We're going to skip to 5.3. All right, so the way we've graphed things before is what I'm showing you kind of on the left. Okay? You've got an x and a y axis. X is horizontal, y is vertical. And this kind of graphing works great for certain things, right? Especially if you want to draw lines with like slope, rise over run. You can usually count things like that, y-intercept. You know, that kind of graph paper is perfect. But if you want to draw circles on that graph paper, it's not as convenient. Okay, there's another form we have which is called polar form. So what I'm going to do, and we're not even going to get into anything this complicated, and you definitely don't need a graphing calculator. But I'm going to show you what the equation of a circle would look like if I were to try to draw it using the xy axis stuff that we're used to. I'm going to show you how much stuff I have to type in. And then I'm going to change my calculator to polar and show you how much easier it gets. All right, so if I wanted to graph a circle, okay, I got to pick a circle that's a certain size. Let's do a radius of 4. So I'm going to make a circle with a radius of 4 units. I would have to type in the square root of 4 squared gives me 16 minus x squared. Now watch what happens when I graph that. Let's go zoom square. Is that a circle? No, how much of the circle is it? Yeah, it should look like it's about half. There's going to be a little gap in it, and I can't really fix that. But to get the bottom part, I have to basically do this. So I have to type in all this stuff just to get something that kind of looks like a circle. That's the best I can do, right? If I want to graph it using this calculator, using a x and y axis. Right? So just keep in mind all that stuff we had to type. Let's put it over there. Now, the calculator has a mode called polar. We're never really going to get to use the graphing calculators to graph stuff in polar in here, because we're only going to graph. We're going to spend like 1 day on graphing, maybe a day and a half. So we don't get into it that much. But if we actually got into using the calculator and then graphing something in polar, all I have to do is type in that one number, and that's it. So you just to kind of compare it. Look how much, well, I don't know why I did that. But look how much stuff I had to type in here. All this square root stuff, look how much stuff I had to type in polar. Much, much easier to draw a circle in polar. It's a better tool for doing that. Likewise, if you wanted to draw lines, the best way to draw a line, simplest, y equals mx plus b. If you want to say, well, could you draw a line in this new polar system stuff? Yeah, you can, but lines become very complicated because polar is set up to draw things that are circular. It can do lines, but it gets just as complicated as what I just showed you. Okay. And what's kind of cool in polar is you can do, I'll just kind of show you guys a few graphs. You can draw things that spiral. Okay, that's not really something we can draw with an xy axis. We can draw things like this. Well, it's kind of small, but if I zoom in, you'll see it better. Kind of like a little flower with 8 petals. So you can get into kind of some different looking graphs that you probably haven't done before. All kinds of stuff. So again, polar, pretty cool for graphing kind of new things, but we're not going to get into graphing anything that fancy. So when you graph in polar, okay, they don't call it an x-axis anymore. They call it a polar axis. Okay, our book doesn't really give a name to the vertical. So if we have to call it something, we'll just call it the vertical axis. So your polar axis is horizontal, and your vertical axis is up and down. Now, I've labeled degrees going around this circle. Okay, degrees is going to be a big part, or radians, but whatever you use, an angle is a big part of drawing something in polar. Okay? Just like an x and a y coordinate, that's a big thing of graphing a point. You've got to know an x and a y coordinate. You're going to have to know an angle here. Okay? That's one of the two things you're going to need. The middle point, you can still call it the origin, but they usually call it the pole when you're graphing in polar. Okay. There are some graphs in polar on the homework. So what you can do is, I didn't print out any polar graph paper, but once you draw a polar axis one time, then you could just label all the homework problems like number 2, number 8. You could use the same grid for every problem in the homework. Just label which point is which from the book. Okay. Something like that. So, rectangular coordinates are written as x, comma, y. Well, polar coordinates are still written with two things. But it's not an x and a y. It's an r and a theta. Now, we're dealing with a circular grid. What do you think r stands for? Radius. Right? It has to do with how far away from the center are you? How far out do you move? And then theta has to do with an angle. So a typical coordinate in polar would look like that. 3, 120 degrees. Or 5, pi over 4 radians. Those are all points in polar. And we'll practice graphing them after. So to graph a point in polar, you kind of do it like it is in rectangular. You start with the first number, do what that tells you to do, and then go to the second number, and then do what that tells you to do. So basically there's a decision you have to make with r. You're either going to move left or you're going to move right. What do you think would control whether you move left or right? What kind of values for r? Either these values or these values. Positive or negative. And it's going to be the same thing for the angle. Positive is going to be one direction, negative is the other. Okay. So you're going to start at the pole, or the origin, and you're going to move out the number of rings indicated by r. If r is a positive number, then you're going to move to the right. Okay, so if r is positive, you move right. That's kind of like it would be with an xy coordinate. If the x value was positive, you move right. So if the r value is less than 0, which way do you think you would move? Left, yeah. So if the r value is less than 0, you're going to move left. So r tells you left and right movement. Okay, and that's the first part of the coordinate. Now, the second part of the coordinate has to do with an angle. Now, when you're moving on a circle, or when you're moving like in circular motion, you don't really have left, right, up, and down. What are the two directions you can move when you're moving on a circle? Yep, clockwise and counterclockwise, right? Which way is which? Well, it depends if the angle is positive or negative. If your angle is positive, okay, if it's bigger than 0, you're going to go counterclockwise. Counterclockwise is this way. Counterclockwise. If the angle is negative, okay, if it's less than 0, then you're going to go clockwise. That's that way. All right. So r, left, right, theta, clockwise or counterclockwise. So all we're going to do now is we're just going to practice graphing points. We'll look at every kind of possibility you could have. Positives, negatives, stuff like that. So, any questions on that so far? All right, so let's take a look at how we graph some points. So, my graph paper is set up so that it has these lines coming out from the pole, and it puts one every 15 degrees. So that's 15, 30, 45, 60, 75. Right? That's just how it's set up on my graph paper. Okay, it's every 15 degrees. And the size of the rings, breaking things. The size of the rings here, we've got 1, 2, 3, 4, 5, 6. Some polar graph paper could be smaller. Okay, like if I have, let's see if I have a smaller one. Yeah, so that one is a little bit smaller rings, so it's kind of packing in more for the radius. Notice the angles didn't change. It didn't, that never really changes. I mean, 15 degrees is always 15 degrees. You can't change that. And then I have one like this where the lines get even smaller, so it's actually, I think it's kind of hard to see. So that's why I usually stick with this one. But I can only graph out to 1, 2, 3, 4, about 6 units. But I'm not going to give you any that are bigger than 6. So. All right, so when we look at that, first thing we want to do is just figure out which one is R, which one is theta. Right. So Jake, out of these two numbers, which one of them is R?
One of them is R. Degrees.
Not that one. That's going to be my theta.
That's the theta. The 3 is the R.
Yep. So that's going to be R. That's going to be theta. All right. So Aiden, what kind of number is R? Positive or negative? Positive. And do you remember what we do if R is positive? Like I know I'm going to move 3 units, but do you remember which way?
To the left or to the right?
To the right. Just like an x coordinate. If it's positive, you go right. So 1, 2, 3. Now I'm going to erase that little mark I put. Okay, that's just a temporary mark to remember. Okay, I'm going to start from there now, and now I'm going to go 120 degrees from that mark. All right, but I got to remember 120 degrees which way. So Aaron, 120 degrees. It's a positive number. Which way do I go for positive? Let's double check. So, if the angle is bigger than 0, which ours is? Counterclockwise, yeah. So, counterclockwise, 120 degrees. Right? So, I'm going to go 90, and then 15 and 15 more. Right? I go 90, but then I had to go 30 past that to get to 120. And that is my answer. That's how you graph the point 3, 120 degrees. Questions on that? Okay, so that was a positive radius, positive angle. Let's look at another positive, but what's different about my angle this time? Yeah.
It's a fraction.
Okay, it's a fraction. What else is different? Yeah. It's in radians. If you're comfortable with radians, you don't need to change it. If you can do the problem with it in radians, just go for it. But if you're not sure what it is, you might want to change it. So can someone tell me what is pi over 4 radians if we change it to degrees? Remember? Well, how do we change radians to degrees? What do we have to do? Okay. So 180 over pi. And if I do that, what's going to happen? Pi's cancel out.
4 times 180. No, 4 divided by 1. No.
Alright, so what do I have to do now? Well, William?
Oh no, I'm scratching my back.
Well, what would you do if that was your calculation you had?
Would it be 180 divided by 4?
Yes. And what would that come out to?
Yeah, 45.
45. Alright, so now we know that's a 45-degree angle. Now I want to graph it. So Kate, what would I look at first? The 5 or the 45 degrees?
The 5.
Yeah, we're gonna look at the 5 first. And that tells me to move, how about, Ben, how many units am I gonna move?
3.
Where'd you get the 3 from?
I don't know. The 3 numbers. 5.
Yeah, right, my radius this time is 5. So, 5 units which way?
Right.
Right. So we're going to go 5 units to the right. 1, 2, 3, 4, 5. Again, just put a little mark there. You don't have to, but just remember that's where you're going to start from. And now, Connor, how many units am I, or how many, from there, what's my angle?
45 degrees.
45 degrees, which way?
The left.
Well, it's circular movement, so
Clockwise.
counterclockwise. So we're going to go 15, 30, 45. And that's your answer. And that's it. So you graph the point 5 comma pi over 4. Any questions on that one? All right, so that was another positive. Let's try one with a negative. So now we've got positive 5, negative 210. All right, so Libby, for my radius, how many units am I going to move?
5.
5. And then which way?
Clockwise.
Well, the radius, you're thinking of the angle. So 5 units to the right. 1, 2, 3, 4, 5. So we're going to start from there. And now she already told us we're going to move clockwise 210 degrees. So 210, well, if I go halfway around, how much is that? 180. And then 30 more brings me to 210. So I went halfway, and then 15 and 15 more gets me to 210. Right, and that's how you graph positive radius, negative angle. Any questions on that one? All right, let's switch where the negative is. Now we've got negative radius, positive angle. So we get negative 3 comma pi over 2. Which, again, we might want to write it in degrees. What's pi over 2? That's 90, right? Just double what we did before, pi over 4. So that's 90. All right, so Jose, what's my radius here? Or actually, just tell me, what number am I going to look at first? Yeah, and because it's negative, it tells me to go which way? Left. So 1, 2, 3. So we're going to start from there. And Peter, I'm going to move how many degrees? Just how many degrees? 90. Which way?
Right.
Remember, your angle is a circular movement.
So
Counterclockwise, yep. So we're going to go 90 degrees counterclockwise. So that would bring me right down there. And that's the answer for that one. Now for this one, I'm going to draw how I actually got there. Okay, I went left 3 and counterclockwise. Does anyone think they could give me another coordinate? And I want to get to that exact same point. And I'll try to do it in a different color. Or not. I'll change the color after. So can someone give me another way I could get to that same point? But I don't want to have negative 3 comma positive 90.
So could you just do the opposite, like positive 3 and negative 90? Or
So positive 3, 1, 2, 3, and then negative 90 would bring me that way. So positive 3, negative 90. And what I'll do is, I think I can just make that, let's make it red. And we'll make all that red. Okay, so that's another way I can get to the same point. Let's see. Oh, the colors aren't working. How about another way? Besides those two.
3, 270.
All right, let's try that. 3, 270. So that's right 3, and then 270 degrees counterclockwise. Brings me right there. Yep, so that's another way. Let's make that one green. Very green. All right, so we got that. So that's a third way. How about a fourth way? There's one more way. We've got the negative, positive, positive, negative, positive, positive. We're looking for the negative, negative.
Negative 3, negative 270.
So negative 3. Let's try that. So left 3, and then negative 270 is bringing me around clockwise. Yep. So negative 3, negative 270. All right. And I'll put that one in which color?
blue?
Blue.
The baby blue.
The baby blue. Is that?
No.
Is that
Over.
over?
Other way.
Oh,
Light blue. Yeah.
that one?
No, underneath that one.
That one?
No, that one.
No.
That one. That one's a good one.
Yeah. That one?
No.
No, that one?
No red. No, wait, we're gonna
Oh, take it.
No, you're literally missing
Yeah,
out.
Oh.
What are you talking about?
No, I was talking about the one that you put first. Oh.
So there's your different ways. So how many ways does it look like you can get to that point? 4. There's 4 basic ways. Your radius can be positive or negative. Your angle can be positive or negative. Writing this in radians or degrees, that's not a different way. That's just changing your units. Also, if you said, well, could you do something like go right, go around, and then keep going, and then stop the second time? That's not really a different way. You've still gone right, you still went counterclockwise. You just went counterclockwise a bunch of times, all right? So there are 4 basic ways to get to a point in polar. And I'll tell you why I'm showing you that in a little bit.
So you're going left and right. Why can't you go like up or down?
Because it's just kind of like when you have the x-axis, like when you have a coordinate like x and y, this number always means left and right. It just can't mean up and down.
Okay.
So our first number always means left and right, and our second number always means clockwise or counterclockwise. There is no number in polar that means up or down. There isn't one. Okay. So now if let's go back to that first slide I showed. Let's say I wanted to get to this coordinate right there. What's the coordinate for that point?
3, 1.
3, 1. What's a different coordinate to get to that same point? Like I just did before in polar. I came up with different coordinates to get to the same point. You can't. Okay, in rectangular, you can't do that. So that's a huge difference between polar and rectangular. Rectangular, there's only one way to get to each point. Polar, there's multiple ways to get to each point. All right? So I'm not going to go through all 4 ways for each point. But the reason I'm showing you that is because when you get to a point where you're figuring these out, if it was a multiple choice question, maybe you figure it out and you'll get this one, the way you do it. Okay, the way you type it in on the calculator, whatever your calculator does, you'll get that answer. But maybe if it's multiple choice I'm going to write that one. Well, they're the same thing. You just have to know that there's different ways to write the same answer. And the easiest way to figure out the different ways is just to draw it. You could try to come up with formulas like, all right, well, if I've got the positive and the positive, if I just take the positive angle and subtract 360, that'll give me the negative one. So you could try to figure out like shortcuts to do it all, but for me, I like to just visually see it and then just look where I would have to go. Right. I think that's the easiest way to get all the answers. All right. That's another negative. We kind of did a negative here, this last one that Kyle gave us. So we probably don't need to do another one. Let's do this one. 0, 300. So what's my radius here?
It's just at the pole.
So, well, what's my radius?
0.
0. So it's not really moving left or right, but then what's the angle?
300.
300. So what you have to do for this one is you've got to point 0 units from the origin, but it's rotating 300 degrees. So you want to go about like that. Right there. And that's how you do it. Yep.
So I can just draw it out on there.
Well, when you draw it, the way I can check on your test is you put your pencil down and then just spin it.
How do you know
Like
it's
that.
spinning?
I can tell because I look for the spin factor. I look for the spin factor.
Is that real? Do you
No.
just make that up?
Yes. So you put your pencil down and you spin it. Spin factor. All right, so basically it just stays at the origin. Okay, 0, any angle, it's going to stay right at the origin.
We're gonna have a graph of this on the test, and we have to draw it out.
If there's one you have to graph, the grid will be on the test. Yeah. Yep. All right, how about this one? So this is the last type we could have. Now we got the 0 in the other spot. Is this going to stay at the pole? 1, 0 degrees. No. This one's going to move off the pole. So which way does it move? Right? How many?
1.
And then what?
Nothing.
Nothing. Just stays there.
I like these ones.
So anytime this number is 0, all that happens is it moves left and right. If the other number is 0, it's just like it spins in place at the origin.
For the spin there.
The spin, yeah, spin factor. SF. All right. So any questions? I've given you kind of one of everything: positives, negatives, and zeros. All right. So now I want to take this point, which is 3, pi over 6. What would that be in degrees? It's probably going to be easier to do it in degrees. 30, yep. So 30 degrees. Remember, pi is 180. So if you multiply, if you do it out, your pi's would cancel, and 180 divided by 6. Now, I want to write this point 3 different ways. That's a positive. Okay. First thing I want you to do is write it with a positive radius, but I want an angle that's bigger than 360. Okay, so if you just remember in your head, there's always something you can add or subtract to an angle to make it bigger or smaller. Right? So I want an angle bigger than 360. So it's kind of like I'm going around an extra time and then stopping. The second way I want you to do it is I want the radius to be negative, but I want the angle to be positive. Okay, so negative radius, positive angle. And then the third way, I want the radius to be positive, but now I want the angle to be negative. Okay, so we just went through some of those on the other page. Okay, so I want you to try and see if you can write it 3 different ways, and that grid might help. Okay, 3, 30. You're starting there. Okay, that's your point. Right, so take like a minute or two and see if you can figure out how to write that point different ways. And remember, each section here is worth how much? Like each each wedge of this circle? 15 degrees. Yeah. Depending on your graph paper, it might not have as many or it might have more. But my graph paper divides it into 6 sections per quadrant, if you want to think about it like that. Okay, so 15 degrees. All right, so we're trying to figure out 3 different ways to write this point in polar. Does anybody remember what can you add or subtract to an angle? Yeah, you can always add or subtract 360. So, if in this case they want the angle bigger, would you add or subtract 360? Add. So what you basically want to do is this. Now, we've already said that doesn't really count as another way. You're just going around more than once. But for whatever reason, they just want you to do that. So what would the coordinate be for what I just drew?
3, 390.
3, 390. Yep. 3, 390. Any questions on that? Perfect. All right. Let's take a look at the second way. Now, this time they want r to be less than 0. Well, if r is going to be negative, you only have one choice. What does r have to be if it's going to be a negative number? It's got to be negative 3. If it's not negative 3, you're not going to be on the third circle. Okay. So, starting from here, and now they want the angle to be between 0 and 360. So, which way do they want me to move? Clockwise or counterclockwise? Counterclockwise. So we're going to go like this. So, how many degrees do I have to move to get where I just drew? 210. Yep, 210. So you go halfway, that's 180, and then you're going 2 more sections. And each section on my grid is worth 30. So that's 210. Okay. Any questions on that one? All right. And let's do it one more way. Okay, last way. They want r greater than 0. So how about Kayla? If r is going to be greater than 0, what does it have to be?
3.
It's got to be 3. If it's not 3 or negative 3, you're not on the third circle. So we're starting from here, and negative means we're going to go which way? Clockwise. We're going to take the long way around. So clockwise, negative angle. But how much is that? Negative, how much?
290.
How much?
330.
330. Right? You've gone almost all the way around. You're 30 degrees short of going all the way around. So that's negative 330. All the way around would have been negative 360. Okay. Any questions on that? Okay, the last thing we're going to look at is how we can change from polar to rectangular. And this will also be the first thing we look at tomorrow, the other way. Okay. But today we're going to go from polar to rectangular. All right. So can someone remind me, in polar, what 2 things do they give you for a coordinate? They give you this value, and they give you this one. That's in rectangular. So when you're doing a rectangular coordinate, that's the goal. You need a left and right, and you need an up and down. But in polar, you need
Radius and degree.
you need a radius and
Degree.
a theta. You need an angle. Whether it's degrees or radians, it doesn't really matter. Okay. So R is, what is that? It's the, how would you explain what that is in polar? It's the what? Yeah, what does that mean? Like as I said, I don't know, what do you mean?
How far from the center?
How far from the center, yes. That's your radius, all right? And theta is the angle with the polar axis, right? Whether it's clockwise or counterclockwise, where I put the point, it would be counterclockwise. Right? We would be going that way in this case. Right? I didn't actually put the circle in. It doesn't really matter, but there's the point on the circle. I don't know how far that point is from the pole. It's r units away. All right, so I've been given this and this, but I want that and that. So when you talk about x, that's a distance, but what does x mean? Like when you're graphing a point, it's what kind of distance?
Horizontal.
It's horizontal distance, right? So if we start from here, the question is how far to the right do I go? And then y is your vertical. How far up do I go? So that's what I need to do. Instead of figuring out a radius and an angle, I want to figure out a horizontal and then a vertical distance. So what shape do you think I could make out of that that would help me figure that out?
A right angle.
Okay, I'm going to make a right angle. And what shape is that going to kind of turn this into?
A square.
Triangle.
Triangle.
Yeah, let's go with a triangle. So, there's my triangle. So, what I want to know is, color is still eluding me. Okay, so I want to know this distance first. What would that distance be that I just traced? That would be your x value. Yeah. So I usually try to show it in a different color so it's easier to see. So there's your x. That's there. And now I want to know this value. What would that be? That's your y. So to convert from polar to rectangular, you basically have a triangle where you know this and you have to find that and that. So you've got two sides, you've got a side and an angle, and they want you to figure out the other two sides. So let's see if we can figure them out. I'm going to circle the things you would know. In the problem, they'll give you that, and they'll give you that. Now I'm going to circle what you have to find. That. Okay, we'll do y after. So I know the name of the bottom side is x. What's its position in this triangle? Relative to theta. Where is x? It's adjacent, right? X is the side that's adjacent. It's right next to theta. Now, what about r? I know its name is r, but where is it in this triangle? It's the hypotenuse. So hypotenuse, adjacent. Those are the two sides I'm using. What trig function involves those two? Adjacent and hypotenuse. Cosine, yep. So the formula to find x is going to involve cosine. So I have the cosine of my angle equals adjacent over hypotenuse. Now fill it in. Adjacent is x, hypotenuse is r. Now the only thing I want to do is get r on the other side so I have x by itself, and that's going to be the formula to find the x. So how would you get the r on the other side?
Multiply by both sides.
Yep, multiply both sides by r. And that is the formula for how you calculate the x value. So now that's not a question mark. Now we know how to do it. You just fill in the r in the theta. Great. Now, let's do the same thing for the y. What position is y in? It's not adjacent, because we just used that. This is what? Opposite. So now to do y, I need a trig function that has these two. Sine. So we're going to set up pretty much the same thing. Sine of my angle equals opposite over hypotenuse. Y over r. And when I get y by itself, what's the formula for my y value? R sine theta. So every time that you convert from polar to rectangular, you're really just figuring out two sides in a triangle. That's what you're doing. Now, what trig function didn't I use here at all? Out of the three basic ones. We didn't use tangent. Well, that's because tangent is going to be used when we go the other way, right? When we want to change tomorrow, when we change it back the other way. All right, so this is same formulas you just wrote down. So to convert from polar to rectangular, they'll give you a point in polar, they'll tell you the radius and the angle, and you use these two formulas to change between polar and rectangular. So x equals r cosine theta, and y equals r sine theta. Any questions on the two formulas? Now, if they give you a problem in radians or degrees, I usually just keep it the way they give it to me. I'll change the mode on my calculator if I need to. With drawing, I usually change it to degrees because for me that's easier to visualize. But if you're just going to type something in on a calculator, the calculator is going to do everything for you. So just make sure your calculator is in the right mode. Right, so let's look at this one. 6 comma pi over 6. Before I even start, what mode should I make sure my calculator is in? Radians. How do I know it's not degrees? Because there's no degree symbol there. If there was a degree symbol, then I'd put my calculator in degrees. Right, so I think my calculator is already in radians. Yep. All right. So next thing I'm going to do now is just write down the two formulas. X equals, Y equals. So I want to use the formulas that I have right up above. Just fill in what I have for R and what I have for theta. Right, so Jasmine, what is going to be my formula for X?
R cosine theta.
Yep. And can you tell me what I would put in my case?
So 6 cosine pi over 6.
Yep, 6 cosine pi over 6. And I'll hold off. I'm going to do that out in a little bit. And how about, Libby, my formula for y?
6 sine pi over 6.
6 times sine of pi over 6. Okay, and now I'll do that one out. All right, so let's type in 6 cosine pi over 6. Right, and we get about 5.20. So that's my x. And my y, 6 sine pi divided by 6. We get 3. So the last thing is just write that as a coordinate, right? Because we're converting it to a rectangular coordinate. So x, comma, y. And that's the answer. Okay, any question on that? Right, now I'm going to show you a way that I can check that answer and see if it's right visually. If you had a graphing calculator, you could probably do it. If you had like a computer, you can't really do this just with a piece of paper. But let me graph that point, 6 comma pi over 6. So that's 6 30 degrees. So I went 6 units right, 30 degrees counterclockwise. Any question on that, or does anybody think that I put the point in the wrong spot? Okay, so now what I'm going to do is, that point is going to stay right where it is. All I'm going to do is change the background behind it. I'm going to change it to a rectangular grid. And if we've done it right, this point should look like it's a little more than 5 units right and exactly 3 units up. So let's change the background behind the point and see what happens. You know what? Might have to make it single page to do it. Let's do it like that. Now, look at where that point is. Does that point look like it's a little bit more than 5 units right? Yeah? Does it look like it's 3 units up? Yeah. It ended up exactly where it should have. 5.2, comma, 3. So there's the point in rectangular. There's the same point in polar. And that's it. So that's kind of a way I can check the answer on here. Any questions on that? Okay, we'll try one more converting from rectangular to polar. All right. So the point here is -4, 120 degrees. What's the first thing I should do before I start anything?
Change your calculator to degrees.
Yep, you should put your calculator in degrees. If you type it in the way this calculator is set up, it's going to be wrong. All right. And most of the time, in fact, pretty sure all the time, the calculator is not going to give you an error and say you're in the wrong mode. The calculator is just going to give you a number, but it's not going to be the right number. All right, so change to degrees. Now that doesn't affect what I'm going to write down for my 2 formulas. My formulas are the same. It's just when I type them in, the calculator will do it differently because now it's in degrees. Okay. What's my formula for x? -4 cosine 120. And my formula for y? Negative sine 120.
Sorry, -4 sine.
Yep. All right. So let's see what we get. -4 cosine 120. We get 2. A lot of times, I don't know if you've noticed a little bit of a pattern, but when your angle here is a multiple of 30 or 45, one of the answers comes out nice, the other one comes out to a decimal. That's usually what happens. Not always, but usually. And then -4 sine 120, this one is not going to come out to a nice number. Okay, it's -3.46. So the coordinate is 2, comma, -3.46. Okay. Any questions on that? All right. Now, on the test, you might see the answer written this way. Let's see, 2, comma. You might see it written like this. I don't know how I got that. So this goes back to unit circle trig. Right? Whenever we had angles that were multiples of 30 and 45, there was always a way to write the answer out nicely. The nice answer usually involved square root of 3, or what was the other square root that came up a lot? Square root of 3 came up whenever the angle was a multiple of 30, and the square root of this number came up with 45s. So square root of 3 was one number, but anyone remember the other number with the 45, 45, 90? Square root of what? No, it was the square root of a number you can't do in your head nicely. Square root of 2. So square root of 3 and square root of 2 are the two numbers that come up a lot. If you don't remember unit circle trig, Okay, the way around it is if you see this answer on a test and you get this answer from your calculator, just change the answer on the test to a decimal. Type in -2 square root 3 and see what it comes out to. Oh, -3.46. So that is exactly the same as your answer. And that's the easiest way around it. Just take the answer, change it to a decimal, write it down, and see if it matches yours. Okay? So any question on something like that? Okay. The other way around it, so you don't have to change things to decimals, involves remembering everything we did with unit, circle, trig. So it's probably easier to change it to a decimal. All right. So that's the first part of polar coordinates. Okay, changing and plotting points. Okay. So homework tonight, it's all even, and you've got just under 20 minutes left. Okay, so you got enough time. You might be able to get most of that done. My suggestion is for the problems you have to graph in polar, just go like this. Just draw, somewhat nice grid, that's nice enough. Just draw it one time, and then label each problem in the homework like number 12, number 14. Just use the same grid for every problem. Okay, if you really can't draw a grid in polar, let me know, I can print one out for you. But if you can draw like that, you're good. That's all you do.
Are there evens for both of those?
Those are evens for everything, yep. All evens.